Hello guys, welcome to my channel once again for the problem which I have picked from 1939 Putnam A2 problem. The question stated that let C be the curve such that which follows the equation y equals to x cube for all x belongs to real. Tangent at A meets the curve again at B. This was the condition. Then we had to prove that gradient at B, where it had met again, is 4 times the gradient at A from the point gradient at that point where the tangent was drawn. So because it is all based on differential calculus, so first approach or the first step which I am going to take is to draw the graph. So let's draw it. This is the curve of y equals to x cube. We all know that this is x axis and this is y axis, and this curve is for y equals to x cube. Now let this is the point, we say it A, and I'm going to draw a tangent over here, something like that, like this. This is A, and it has intersected the curve y equals to x cube at this point. Let's call this B as per the question. Now we have to, what we have to prove is, to prove, let's write here, to prove dy by dx at B equals to 4 times dy by dx at A. Okay, in shorthand notation I have written this. So let's start. First I am going to write the equation of this line. So let's start with it. I am going to find a dy by dx for this curve. Dy by dx, because I am going to differentiate this equation, dy by dx equals to 3x square. So this is the equation which will be very useful to us. At a point, what is the slope of this line? What is the value of slope of this line? Because the slope is nothing but dy by dx. So at point A, dy by dx at A, let's call this x1 comma y1, and B, let's call this x2 comma y2. So at A, x equals to x1, we will get 3 times x1 square. And one point over this line is x1 comma y1. So we can easily write the equation of this line. So let's write the equation of line. It will be y minus y1 equals to 3x1 square multiplied by x minus x1. Since x1 and y1 lies on this curve y equals to x cube, so we can write y1 as x1 cube. So this point can also be written as x1 comma x1 cube, and similarly this can be written as x2 comma x2 cube. So from here on I will use this coordinates which I have written in just one variable. So let's rewrite y1 as x1 cube, then y minus x1 cube equals to 3x1 square x minus x1. Now I am trying to find out this x2. So let's substitute, because this line also intersects this curve at B, and the coordinates of B is going to be x2 comma x2 cube. So I am substituting x and y as x2 and x2 cube. So y can be written as x2 cube minus x1 cube equals to 3x1 square comma x2 minus x1. This was the equation of L, but now I have made to satisfy this at point B. So now this is not the equation of line. I have just substituted this point because it is satisfying the line. So this is of the form a cube minus b cube. Let's factorize it. X2 minus x1 multiplied by x1 square plus x2 square plus x1 x2 equals to 3x1 square x2 minus x1. Of course, x2 minus x1 want to be 0 because it will imply x2 equals to x1, which we are not supposed, because these two are distinct points. So I can just cancel it out with this argument. Now let's take all the whole stuff in the LHS side to RHS side. Then what I will get? 2x1 square minus x1 x2 minus x2 square equals to 0. When I will factorize it, because there is nothing logical here, so just I am going to factorize it. 2x1 plus x2 multiplied by x1 minus x2 equals to 0. Once again, with the same logic that x1 minus x2 can't be 0, just I will cancel it out and I will get 2x1 plus x2 equals to 0. So x2 equals to minus 2x1. Now one thing to notice, the main thing to notice is that the derivative or the gradient is just proportional to the square of x. and we have got the relation in the terms of x's. So what I'm going to do is square both sides. X2 square equals to 4x1 square. Now multiply by 3 both sides. 3x2 square equals to 4 into 3x1 square. Now what this part signifies, we can correlate with this. Dy by dx at x equals to x2, which is equals to, we can once again correlate 4 into dy by dx at x equals to x1. So we have got that the gradient at b is equals to 4 times gradient at a, hence proved. This was the question which it stated, and the proof is in front of you. Hope you like the solution and enjoyed the video. If you like the solution, then please press the like button and subscribe to my channel and comment your suggestions. Thanks for watching.